On to page 2 of worksheet day 4, but before I do, I caught myself doing something wrong in the last video. I was unable to think on the fly to tell you, and instead of re-recording the whole thing, I'm just going to talk about it. This is supposed to be a negative here. What I wasn't considering when I did this problem was that I'm doing an arctangent problem. So remember, we're restricting the domain here. So negative 3/2, tangent inverse of that, we are restricted to these two here. So that would throw our reference angle down here of negative 0.983. But when we're considering it where it is, that reference angle is going to be a positive 0.983. So we still then do pi minus this theta right here, which is a positive 0.983. And that gets us to the 2.159 in radians. And then we have the root 13. So just wanted to clarify that. I'm sorry about that if that caused anybody confusion. So moving on to the back page. Let me zoom out a little bit here, and maybe, again, I can just bring some clarification to what's going on these. So when you try these, not worried about you graphing these perfectly. Just a sketch is great, but the calculator obviously helps you come up with that. But I do want you to be able to see that right here, we would want to, multiply both sides by r to get here. So if we did that and got here and then replaced, these are just great connections, and replaced r cosine theta with x, you can complete the square and you can see that it's a circle with a center at 2, 0 and a radius of 2. So that one is right here. Okay? Now, the next connection you really need to make is that when you have an equation in polar coordinates, is points are being created as you put in angle measures. So when I actually put in theta of 0, you have to think about that as, what's my r value, coming from here right now. What is my r value when I put in 0 for theta? Well, cosine of 0, knowing our quadrantals, cosine of 0 is 1, so the r value is 4. So that's an ordered pair. When I actually have an r value of 4, the radian measure is 0, so that's that point right there. Okay? Well, when we put in, say, a different radian measure, if I put in a pi over 2, if I put in a 3 pi over 4, you just have to think about what values, when I put in radians, spit out what r values, and those are ordered pairs, and that will end up making a circle. Okay? Well, the other one, which is right here, is way simpler to think about. Let me switch that over to green so we can kind of see the two different ones. But this is just a circle, radius of 2. So 1, 2, and boom, we have our circle right here. Well, it looks like there's 2 points of intersection, but remember, they have to be simultaneous points of intersection. So how can we do that? We can think about, setting the two equal to each other. So where did this come from right here? We have 4 cosine theta, and that equals our r value of 2. We're just substituting it in there. Divide by 2, cosine of theta equals 1/2, and you got these two values here. Well, that means at pi over 3, which is right here, okay, at pi over 3, which is right here, whoa, that went to white, sorry, right here, we will have a point on the blue circle at the exact same time that the point on the green circle is being created. So like as we say go, this is plotting points along this, and this is plotting points along here, and that is a simultaneous point of intersection. Same thing happens down below, so we get 2 of those. If this is confusing to you, which I can understand it can, the main thing is the algebra will back us up. When we set them equal to each other, we will be able to crank out the algebra. Okay? Now, we will, once again, this is called a limaçon. We will have you graph roses, limaçons, and what am I missing? Oh, cardioids there. And the main thing is, I really hope, I'm even going to write it down right now, there's a whole section on 9.2 notes. There was a section we handed out where it connected, you know, all the difference between A and B here, and if this is less than that, if these are equal to each other, what happens? So I'm encouraging you strongly to look at those 9.2 notes, and kind of just the notes tell it all of how that connection works. But again, I made a scale of 2 here just so we could see this on here. But if you did this on your calculator, you see what's happening. Well, there's an inner loop, okay? So what is the inner loop? Well, the idea is when this starts, it starts creating points. So at some point, when we come around here, there's gonna be values that create this inner loop. Well, when we enter the inner loop, the R value is 0. And then we have R values that come back to 0. So you can see here, if I take this and say, when is R 0, subtract 3, divide by 6, I have a very simple trig equation to solve, and I get R value being 0 here, and an R value being 0 right there. Well, what that means is the inner loop will be on the interval, and actually I didn't write this out correctly as far as a final answer. I just said what theta is. But when we enter and then when we exit, that is what it should look like. So actually the interval would be 2 pi over 3 and then 4 pi over 3. What I encourage you to do right now, I'm not going to do it on the video, but I'm encouraging you to do is to start with a radian measure of 0. Just think about a radian measure of 0, plug it in right here, okay? Put in a 0, all right? You'll get an R value. Then put in some more points, or some more radian measures around here. And as you track the radian measures, you'll really understand that once we put in a radian of 2 pi over 3, our R value is 0. And then what's going to happen? Well, we're going to have different R values in here, let you explore that, but then when they exit, it's going to be at 4 pi over 3. So in this interval of radian measures, we will be creating that inner loop. And if you think about it, here's 2 pi over 3 right here. Just past that, I don't have any values here, so obviously those R values are going to have to be negative for a little bit until they become positive again. All right. So down here, this is a rows. I'm encouraging you, look back at your notes. All right, how do I know that that's a rows? Well, it's the format here. We talked about what where the petals come from and how long the petals are. Again, look back at your notes for that. But this was a pretty basic, do it on your calculator, but then look, cosine of 2 theta, sine of 2 theta, sine of theta, they're both equal to R. So if you can see mathematically, I just set them equal to each other. So when I do that, I am going to do a replacement using my trig identities. I would love to convert all to sine, so I replace. Now what am I doing? I'm going to add that to this side, subtract that because I'm used to factoring when it's in this form. And this is solving trig equation, and I got 1, 2, 3 different answers for this problem. Now, you may or may not have thought there were 3 answers in the intersection of these two, but the algebra leads us there, and those are my 3 answers. Okay? Now, if I'm graphing those by hand, once again, R equals sine theta. If I multiply both sides by R and then replace into rectangular coordinates, a little bit ugly here of completing the square just because that value was a 1 here. But we do get a center at, 0, 1/2 and a R value of 1/2. Okay, but again, can you connect and solve that system is the main thing I'm looking for.